How to build a Blackgates Sweet Pea 5-inch gauge locomotive, part 64. Showing the build quality of the old crossheads made me decide to make a pair of replacements. Do I copy this design or buy a set of laser cut parts? This is one side of one of the crossheads, and this is the good side. The rear piece is not so good at all. If you look at the lines scribed on it and look at the positions of the holes, they don't really coincide. What I would say is these holes and lines are distantly related. Here's a shot without the hideous crosshead in the foreground, and this is the crosshead after I disassembled it. Look at the badly countersunk hole in the large metal block. There's a reason for this. The piston rods are not the same length. This is not the end of the world. In fact, I'm really tempted to make new pistons because the grooves in these pistons have been machined too large to allow the use of commercial cast iron piston rings. If I'm going to have to make some new piston rods, I may as well make the new pistons as well and do it in the collet chuck that I have for my Smart & Brown lathe. By using this multi-size collet system that I've never really used much on these videos, this will make the piston and rod alignment perfect. I'm taking a last look at the badly made parts for the crosshead. I'm not going to throw them away just yet. I need to use them as a pattern to cut some more metal. And I'm going to take this opportunity to do two things. I'm going to attempt to clean up these parts using my whetstone. And I'm also going to answer a criticism from a viewer who tends to send in critical comments. Here we go then, metal cleaning methods for removing marks on surfaces. This thing is called a whetstone, spelled W-H-E-T-S-T-O-N-E, and apparently when this viewer saw me in a previous video using WD-40 and 3-in-1 oil on my whetstone, he typed a comment. I googled the word whetstone with an H in the middle. It is not whetstone without an H in the middle. This piece of very useful workshop equipment is also known as an oil stone. My father had a whetstone. It was literally a piece of stone in a wooden box. When I was a child, I used to be quite puzzled by this piece of stone that my father used. He put oil on it and sharpened knives on it. He also sharpened his woodworking chisels on it, and I never saw him use water. I have a theory that water is not good for these whetstones. For a couple of reasons. Water would make non-ferrous metals rusty, and also the particles of non-ferrous metals in the whetstone would rust, and that is not a desirable thing. Over time, I think using water would cause the surface of the whetstone to become damaged and clogged with rust. Whether I'm right or wrong on this subject, I will continue to use 3-in-1 oil, WD-40, or even steam engine bearing lubricating oil. You may notice that at the moment I'm not using the whetstone. I'm using a piece of 400 grade wet-to-dry sandpaper, which I think is called silicon carbide paper. I want to be accurate because I don't want to upset this viewer, who also leaves critical comments on the YouTube channel of my friend Andrew, which is called Model Engineering Adventures. It's worth a watch. The wet-to-dry sandpaper, covered in 3-in-1 oil, was far more efficient at cleaning the metal surface than the whetstone. This, I think, was mainly due to the grit on the wet-to-dry sandpaper being coarser than the grit on the whetstone. I found this rotary abrasive tool very useful for cleaning metal surfaces, but it's no good if the metal surfaces are very badly marked. I don't always like to polish pieces of steel because when I look at the full size, they're generally not polished. They look like this. Although I do admit I would not like to use this very small rotary tool on a full-size steam engine. I don't know why I'm bothering cleaning up this piece of steel because it's wrong in so many ways. As I removed the piston and rods from both of the cylinders, I was quite surprised to see that the piston rods are different lengths. I've superimposed some arrows on the image so you can see what I mean. This is with both of the piston rods pushed into the cylinder as far as they will go. What I'm doing here is drawing around the original metal plates with a felt tip pen, and this automatically is going to make the cut line a little bit bigger than where it is at the moment on the metal I'm holding. All I have to do now is to remember to cut on the outside of the line. And talking about cutting, it's over to the bandsaw. You will notice how far I'm keeping my hands from the blade, because I don't want to cut my hand off. And here in detail you can see that I'm cutting on the outside of the line, not directly on the line. After cutting a slot quite a long way down this piece of sheet metal, and put it in the machine vise on the bandsaw. That's 2 of them made. All I had to do then was move the part out a bit further and do the same thing again. I used the pieces that I already cut as a template so that all 4 of these pieces of metal would be approximately the right size. In actual fact, they are a little bit bigger than I need them to be. That is to allow for this part of the job. The 4 pieces of metal are clamped in the machine vise as well as the original part as a reference. I've got to be very careful here. I do not want to cut down into the original part because it will be too small. This, by the way, is completely wrong. It is nothing like the construction method shown on the drawing. The main part of the crosshead is meant to be machined from a solid block, which is a much better way of doing it. You may be wondering then, why am I making 4 metal plates? Well, I like to show alternatives. If you don't have a milling machine, I mean I've got a milling machine as you can see, but if you don't have the experience of using one to cut the special shape, which is the main crosshead, then building it up from separate pieces is an option. While I've been editing these sequences, I have decided to buy the parts from Blackgates Engineering. That way I can machine the main crosshead out of a big lump of metal. Drill and tap the relevant holes and use bolts to secure these 2 metal plates to the outer surface of each crosshead. But there really is nothing wrong with doing it the way I'm showing here. It is simpler if you're not very experienced in the use of machine tools. Although you do need to know how to use a drilling machine and how to drill the holes in the right place once you've marked out the parts. I repeat quite a lot of the processes in my videos, and that's not just because I want to. It's because quite a lot of people write in and ask me questions about things I've already covered in the videos. So by repeating some of the sequences, I do it to help make the penny drop. If you don't get that analogy, think about it. Just imagine yourself being an arcade-type game that takes pennies. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.